All right, 2.8, solving inequalities in one variable. So basically, I don't remember if we did these last year at all or not, but basically we make what we call a sign chart to solve these problems because we want to find the x values that cause the polynomial function to be 0, positive, and negative. Okay, so we have a function f of x equals 5x plus 3 times x squared plus 6 times x minus 1. And now, I only care about the numbers that cause a real 0, okay? Because immediately I see the x squared plus 6, I see that that's going to end up causing a complex number, right? A imaginary number. So, I know I'm going to have an issue there, but basically, I'm going to set each piece equal to 0 to find my zeros. That's the very first thing I'm going to do. So, 5x plus 3 equals 0, x squared plus 6 equals 0, and x minus 1 equals 0. So you might recognize, like, I don't know if you recognized right away that there was going to be a problem with the one in the middle or not, so that's why I write it out still usually. But I've got x equals negative 3/5. I've got x equals plus or minus the square root of negative 6, and I'm going to go ahead and throw a line through that one because I know that that's not possible. And then I've got x equals 1. So then what I do is I make a sign chart, okay? So it's going to look like this. We're going to put our zeros on the sign chart, and that's the only thing that's going on here. This isn't like a number line, but they still need to be in order. So negative 3/5 and 1. And then I usually put some dotted lines just to kind of like separate the pieces. So I'm ultimately trying to find the zeros, the intervals where it's positive, and intervals where it is negative. So I already know what my zeros are. My zeros are at x equals negative 3/5 and at x equals 1. But now I need to figure out what happens in each of these intervals until I get to a 0, okay? Because that's typically where it changes direction. So I'm going to pick a number somewhere over here in this interval. So I need a number that's, I'm going to say, smaller than negative 3/5, right? So I need a bigger negative number. So I would say negative 1. That's the easiest thing to plug in. So we're going to plug in negative 1 to each of these little parentheses. So if I plug in negative 1 here, I have 5 times negative 1, which is negative 5, plus 3 gives me a negative. So I'm going to put a little parentheses with a negative sign in it. Because I don't care what the number is, I only care what the sign of it is. If I plug in negative 1 here, negative 1 squared is positive, plus 6 is positive. So I have a positive. Then if I plug in negative 1 minus 1 is a negative. So then if I, negative times a positive times a negative is positive. So I put a giant positive down there, and I know that's going to be one of my positive intervals, but I'm going to wait and write the intervals once I'm done making the whole sign chart. So now I need a number in here. What number do you think we should pick? 0. Always pick 0 or 1 or negative 1 if they are an option. Makes your life easier. So if I plug in 0 for x, what do I get for that one? It's a positive. If I plug in 0 here, it's positive. And if I plug in 0 in the last one, so this whole thing is negative. So then what number might I pick over here? 2. So then if I plug in 2, I get a positive. If I plug in 2, I get a positive. And if I plug in 2, I get a positive. So that one is. Okay, so now what I'm going to do is it's kind of back to like how we were writing domain. We still write them in their intervals like that. So this one is going to be negative infinity to negative 3/5, and these are not going to include ever. So negative infinity to negative 3/5. Union, the other positive interval is from 1 to infinity. And then my negative interval is from negative 3/5 to 1. So I'm going to do another equality one, because obviously the title of this section is Inequalities, so we're going to get to inequalities eventually. So I've got f of x equals x plus 2 cubed, and then I've got 4x squared plus 1, and then I've got x minus 9. Now, I'm going to go ahead and tell you, and this is to the fourth. Whatever power it's raised to, when we're determining the sign that goes in our sign chart, we go ahead and take it to whatever power it is. That's not like, that doesn't like wait till the end or something. So I need to find my zeros. And so you don't need to write them out like this. You can go straight to what their zeros are. So I would have x equals negative 2. I've got x equals plus or minus the square root of negative 1/4, which I know is going to cause a problem, so I can go ahead and put a line through it. And then I've got x equals 9. So I'll set up my sign chart. I've got negative 2, and I've got 9. And again, I'm looking for, I've already got my zeros, so I can go ahead and write them in. I'm looking for positive and for negatives. So what number do you want to plug in over here? Negative 1 isn't in this interval.
Oh, shoot. I meant negative 3.
Negative 3. So negative 3 plus 2 cubed would be? Negative. Then negative 3 squared becomes?
Positive.
Times 4 plus 1 is still a?
Positive.
And then negative 3 minus 9 to the 4th? Positive. So if it's got an even power that it's being raised to, that's always going to be positive. Okay, there's no way for it to be negative, so we don't even need to even take that into consideration, because we know that whatever number it is, it's going to be positive. And obviously these aren't going to come out to be 0 because we've eliminated zeros. So then ultimately this section is negative. All right, in this interval, what would you like to plug in? 0. So if I plug that into the first one, I get a? Positive. If I plug 0 into the second one, I get a?
Positive.
If I plug it into the last one, I get a?
Positive.
So the whole section is?
Positive.
Then the last one, what number do you want to plug in? 10. So plugging in 10, this is still a? Positive. Plugging in 10 to the middle?
Positive.
Plugging in 10 to the last one, I get a?
Positive.
And so ultimately it is positive. Now, a lot of times what happens is that when it hits a 0, it turns around. In this case, it does not. Okay, which there could be a couple of reasons for that. One, we've obviously got repeated zeros because we have multiplicities of 3 and 2 and 4. The other option is I have some non-real zeros, so that could be why. So don't think that, oh, it's because I was getting ready to say usually it's positive, negative, positive, you know, so on and so forth. But it's not always that way, and this is a perfect example of that. So we are positive from negative 2 to 9. union 9 to infinity. So remember, there's a 0 at 9, so we cannot include it because that would cause a problem. And then from negative infinity to negative 2, it is negative. All right, so the next problems, complete the factoring if needed. So sometimes they might not be factored all the way, so we might need to factor them a little bit farther just to be able to get our zeros. But they're going to be inequalities. And it says to solve the polynomial inequality using a sign chart. Now, up until this point, they have asked us to write down the zeros, the positives, and the negatives. With inequalities, okay, inequalities are greater than, less than, greater than or equal to, or less than or equal to, right? Well, that was fun. So, we are looking for what would make that true, okay? And they're all going to be something of 0. So if it's less than 0, I care about negatives. So my answer, my solution set is only the negative values, okay? So what I like to do is I like to write off to the side once I do the problem. Before I even start, I like to write what I'm going to need. So if it's an or equal to, I will say something like including zeros. If it's just less than, I'm going to say negatives only or something like that because that clues me in to go back at the end when I've solved my sign chart of what I'm looking for. So 8, I've got 2x plus 1 times x minus 2 times 3x minus 4 is less than or equal to 0. So, before I do anything else, what am I looking for in this problem? Since it's less than or equal to 0. Negatives, including 0. So now the process is exactly the same as the problems that are equalities. It's just now the solution is going to look different. So my zeros are where?
X equals negative 1/2. X equals 2. X equals 4/3. Jinx.
Buy me a Coke.
Yes, you owe me a Coke. Except if you're in a reserve.
All right. So now sign chart, same way. Now this one, make sure you notice 4/3 needs to be on the sign chart before 2. And even though obviously these numbers aren't like evenly spaced, I still will pretty much space them evenly because I need to have room to write in my sign chart. All right, so to the left of negative 1/2, what number would you like me to pick? Negative 1. So if I plug in negative 1 for the first one, I get a negative. If I plug in negative 1 to the middle one, I get a. And if I plug in negative 1 to the last one, I get a. So what is that ultimately? What number should I pick here?
1.
You want to pick something easier?
I mean 0.
I mean, we can do 1. That's fine. I was just, if I plug in 0, I get
Positive.
middle.
Negative.
Last one,
Negative.
negative. So that one is
Negative. I mean positive.
positive. Now, this next one is your nightmare. Because the only thing that I can, well, there's obviously infinite numbers between here. But the only thing I can really deal with is what?
1.5. Wait, no.
Okay, well, I guess there's more than one option. I was thinking 5/3.
Oh.
But Josh is like, what? I was thinking 5/3, but you know, whatever works for you. 1.5 is bigger than 1 1/3, so if you want to do that, that's fine. So a positive 1.5 gives me what?
Positive.
Positive 1.5 gives me
Negative.
negative, and a positive 1.5 gives me.
Negative.
You're right, it was positive.
Oh, okay.
I just had to check.
Yeah.
Because I used different numbers when I did it, so I was going back to look and make sure it was right. All right.
Would it still come out the same though?
It will. That's why I was saying I was looking to make sure that what I had on the paper matched what she
Sure.
said, because I was trying to process it. Because 5/3, the 3's canceled, so I was left with 5 minus 4.
Well, I just saw more 2's, so it made sense.
So then this one ultimately is negative. So then over here, what number?
3.
Plug in 3 to the first one, you get
Positive.
second one,
Positive.
third one.
Positive.
So it's positive. Now, I want negatives including 0, okay? So that means now I will use the bracket, okay? So negative infinity, obviously that's still parentheses, to negative 1/2, including union 4/3 to 2, including on both. All right, let's try to do one more of these, and then that way I could give you like 1 or 2 to, you know, have for the quote-unquote weekend.
So when we're doing the ones that are less than like or greater than or less than or equal to, that like will include every number except like infinity. Obviously, it's can't.
Right.
Okay.
Yeah.
And then the
And obviously only like the negatives or
Yeah.
only the positives, not both.
So if we were greater than though, we would just do the same thing but only do the positives.
Yep.
Okay.
So like this next one will be a greater than. So 2x minus 7 times x squared minus 4x plus 4. So this is also one that is going to need to be factored more. But again, first and foremost, what values am I looking for with this one?
Positives.
Positives,
Not including 0.
not including 0. Now, what does x squared minus 4x plus 4 factor into?
X.
X plus 2x minus
X.
That would be a difference of
minus
squares.
2 squared.
X minus 2 squared. Okay, it's a perfect square trinomial.
I was just
Not a
Yeah,
difference of
because you
squares.
was rambling on and I couldn't think.
I just thought I'd throw something out there.
So that means my zeros are where?
X equals 7 halves.
Yeah.
And x equals 2.
So sign chart. Now 7 halves is bigger than 2. So. And if you need to rewrite them as like decimals to like think about them, that's totally fine.
Okay.
Also. All right. So what number are we picking over here? 0. So if I plug in 0, this is negative. And you probably want to actually use this one just because it's easier. Plug in 0, it's,
Negative. I mean positive.
and say this term is squared, so that means it's always positive. So that whole section is negative. I always love it when it kind of like makes a little face.
It's like it's winking.
We do this with I don't know if it's in this section or not, but it is with rational functions as well. And so it's kind of cool because you'll have like pluses and minuses over pluses and minuses. Anyways, it ends up just looking like little faces, and it's always cool.
At the end of the chapter, just play emoji Uno to celebrate.
We'll see. What can I plug in here?
2.5.
3.
You can't
Or
put 3?
well, yeah, because 3 is smaller than 7 halves.
Go with
Oh.
3.
So yes. So if I plug in 3, this is
Negative.
negative, and 3 here is, so that's also going to be negative. It's like a little winky face. And then over here I can plug in,
4.
plugging in 4 here I get,
Positive.
and plugging in 4 to the other one I get. So that equals a positive. All positives don't really look like a face. So then positives not including 0 going to be 7/2 to infinity. So now, just to give you kind of a preview of the rest of them, it shouldn't take us long to get through the rest of them on Monday. But basically, the only thing that's different about the rational ones, we'll start with equalities and then we'll do inequalities, so they'll work the same way. But the only difference is, what can I not have in a rational that I didn't have to worry about with these ones?
Square root.
Rational functions are what? What do they look like?
Fractions.
Fractions.
Oh, 0 in the bottom.
So I can't have a 0 in the bottom. So when I look for zeros, I will be using the numerator to find my zeros. I will be using the denominator to find what's undefined. All of those values will get put on your sign chart. Undefined will also get put there. But even if it's something where it's including, we cannot include on an undefined one. So when we label them, we're going to make sure that we label which one is quote unquote undefined. I usually put like a slash through the number in another color so that we know when I go, if it's an equal or an inequality especially, that I cannot include that. So we'll do a few examples like that. I've got about 4 more examples. If you wanted problems for what we've done so far to look at, it would just be 3 and 9 is what I would assign you at this point. So 1 equality, 1 inequality. And then basically we're moving into rational ones. And I'll add 1, 2, 3, 4, 5, 6, 5 more. It looks like on Monday. And some that are a little harder than what we've done also, that are still this tight, but predominantly rational is what we're concerned about.